Please title these notes Applications 5 Notes Accumulation and write today's date. By the end of this lesson, you should be able to use an equation for the rate of change of a quantity to find the total change of that quantity. Let's start off with the interpretation of some symbols. So if you have an equation R of t for the rate of change of a quantity, and this is really key, it has to be an equation for the rate of change. Typically it's going to be in terms of time. Then the integral from a to b of R of t is what we call the accumulation, or the net change overall. Of that quantity from time t equals a to t equals b. That time piece is important, shows up a lot on the AP test. The units are the numerator of the R of t units. So for example, if R of t is people per hour, then the integral of R of t is going to be people for units. 1 over b minus a, the integral from a to b of R of t. This is different. This is the average of R of t, or the average rate of change of the quantity. The units are the same as R of t. And finally, R prime of t, I should put in here average rate of change of the quantity from t equals a to t equals b, same as up there. R prime of t is the rate of change of R of t, which gets a little bit long when you think of it as the rate of change of the rate of change. And then the units are R of t's units divided by the t units. Because this, remember, is slope, so we're going to do basically the y-axis divided by the x-axis. Okay, let's go ahead and do some problems. Calculator is required for all of these. The rate at which people enter an amusement park can be modeled by the equation R of t equals negative 720 times pi over 6t minus pi over 3 plus 720. And that's when t is between 0 and 13. And what this means is it means that T is the number of hours since the park opened at 9 a.m. R of T is in people per hour. Okay, here's our first problem. According to the model, how many people have entered the park by noon? Round to the nearest person. Okay, so the key thing to realize when you're looking at this is that we are given a rate of change. It says right here in the problem, the rate at which people are entering. So we're given R of T in people per hour, and we're asked about the number of people. This means that we're being asked about the numerator of these R of T units. And that's a pretty good indicator that we're going to be talking about accumulation, that we're going to be talking about the integral. So we want to know the accumulation of people from T equals 0 when the park opens to T equals noon. So let's see, so 9 a.m. is T equals 0. 10 a.m., that would be T equals 1. 11 a.m., T equals 2. 12 noon, T equals 3. So accumulation from T equals 0 to T equals 3, that's the integral from 0 to 3, R of T dt, or the integral from 0 to 3 of negative 720 pi over 6t minus pi over 3 plus 720 dt. Now the nice thing about this is that we can just pop it in our calculators. So this is going to be Math 9, which is finite integral, expression, variable, lower bound, upper bound. So, grab our calculators, go to Math 9, there's finite integral right there. So we can put this in using whatever variables we want, as long as we just put what variable in that we're using. So negative 720 pi divided by 6, make sure you're in radians. I'm just going to use x because it's sitting right there for me, minus pi over 3, close parenthesis, plus 720, comma my variable, which is x, comma 0, comma 3. And there we go. Now I'm going to round to the nearest person. 2,725 people. And that's an accumulation problem. It's very, very, very important to have these units. Always, 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 always going to be critical for accumulation. Oftentimes, having the units is worth about as many points on the free response questions as having the mathematics correct. So continuing with that same problem, what is the average rate at which people enter from when the park opens until noon? Okay, so remember average value. That's 1 over, subtract the bounds. Let's see, from when the park opens, we said t equals 0 till noon. That was t equals 3. So that was that same equation again. So we have 1/3, and then that same 2,725 people. So I'm going to take my answer from before, I'm going to divide by 3, and I get 908 people, again round to the nearest person. Now let me be very careful with those units. Average rate at which people enter, so that means it's the same as my original R of t units. R of t was in people per hour, so that's 908 people per hour. At 10 p.m., the gates close. And people can only exit. At 10 p.m., there are 900 people left in the park. And the rate at which people leave is given by L of t equals 1800 minus 1800t, where t is the time in hours since 10 p.m. How many people are left in the park at 10:30 p.m.? Okay, so since t is the time in hours since 10 p.m., 30 minutes is half an hour, so that means that t equals 0.5 right here. The key thing to realize with this problem, and where it's different than the previous one, is that here we have 900 people left in the park, right there. So that means we start with 900, and then the rate at which people leave. We are taking away the accumulation. So this means that the number left is the number at 10 p.m. minus the number who leave. So this is the only accumulation part. You have to really, really watch out for these problems if there's some sort of initial condition, basically. So the number left, the number at 10 p.m., we're told that's 900 people. The number who leave, this is accumulation. Of L of t. because this is the rate at which people leave, so the integral is the number of people who left. So from 10 p.m. to 10:30, and we have the actual equation for that, 900 minus the integral from 0 to 0.5 of 1800 minus 1800t dt. Once again, this we can just stick in the calculator. So math 9, 1800 minus 1800t, or x, whatever variable you want to use, from 0 to 0.5. And we've taken the integral, so now instead of people per hour, we have people. 900 minus 675 means that there are 225 people left. We can also be asked to find accumulation from a graph. The graph below charts the rate at which kittens are born call that K prime of t, in kittens per week starting on March 1st. Estimate the number of kittens born from the beginning of week 3 to the end of week 9. Now, notice there's something a little bit strange about the wording here. Number of kittens born from the beginning of week 3 to the end of week 9. They were starting and ending at different places in the week. So when we look down here at this week's numbers right here, notice that each of these, this is a whole week. There's a whole 7 days in between 0 and 1, another 7 days between 1 and 2, and so on and so forth. So if we think about what we mean by the first week starts at 0 and ends at 1. These numbers are coming at the end of each week. And sometimes this matters, sometimes it doesn't. Sometimes, if we're talking about seconds, for example, the seconds are so close together on the graph that it really makes no difference. But for something like this, where we're talking about the beginning and the end of things, it actually does make a little bit of a difference. The beginning of week 3 is the end of week 2. So we're really starting right here on the graph. And then the end of week 9 is right here. This is because there is no week 0. This is the beginning of the first week, end of the first week, beginning of the second week, end of the second week, and so on. So now what we're going to do is we're just going to estimate the area. But first let's write this. So number of kittens is going to be the integral, the area in this case from 2 to 9. Of k prime of t dt. And so now what we're going to do is we're just going to count those blocks, estimate. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. This is basically a full block. 35, 36, 37. And I think if we put these two together, we get about 38. This is basically 39 right there. If we put this one and this one together, we're a little over 40. And if we put this one and this one together, it's going to be just about 41. So we have approximately 41 blocks. However, notice that each block is not one square unit. This block, notice that each of these goes up by 50, so it's 50 kittens per week, times 1 weeks. So that means we've got approximately 41 times 50, or approximately 2,050 kittens. This kind of problem would typically show up on a multiple choice test. So if you don't have exactly this number of kittens, that's fine. But you should definitely have somewhere around 2,000 kittens, not 200 or some other number. Certainly not 41. For our third problem, we can also estimate from a table. The table gives a rate of the fuel consumption, C of T, of a tank as it drives. So here's T. That's going to be in minutes. Here's C of T. That's going to be in gallons per minute. 1 minute, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1.5, 2, 2, 3, 2.5, 1.5, 2, 1, and 0.5. Notice the units are given right here in this particular problem. Our first problem is to use left Riemann sums with 3 subintervals of equal width to estimate the total number of gallons used from 3 to 9 minutes. In this case, it's not saying something weird like from the beginning of minute 3 to the end of minute 9 or something like that. It's just saying from 3 to 9 minutes, so we can just use the 3 to 9. We don't have to do kind of the weirdo thing we did with 2 up here. So that means that the total number of gallons, that's accumulation, so that's going to be the integral from 3 to 9 of C of t dt. And we can estimate that, it says, using a Riemann sum. So we're interested in 3, 4, 5, 6, 7, 8, 9. And we're doing 3 subintervals of equal width. So here to here, here, here. That gives us 3 subintervals. We're going to be using left Riemann sums. So that means we're going to be using the point 3, 2 to do our first one. Then we're going to use the point 5, 3 to do our second rectangle. Then the point 7, 1.5 to do our final rectangle. So the width of each of these is 2. So that means that this integral here approximately equals 2 times, and then the height is 2. This also has a width of 2, and the height is 3. And this rectangle also has a width of 2, plus a height of 1.5. So if we multiply those out, and our units, so we originally had gallons per minute, so that means that we just have the numerator gallons, because we basically multiply gallons per minute times minutes, and the minutes canceled out, 13 gallons. Next, let's interpret each of the following in the context of the problem using correct units. First, let's do the integral from 1 to 5 of C of t dt. So we said the integral of a rate, that's accumulation, or the total fuel consumed. So instead of gallons per minute, we're looking at gallons. From, and this is very important, t equals 1 to t equals 5 minutes. Here, this pattern is one that we have to be very, very familiar with. Whenever you see that initial division, that means we're talking about average value right here. So this is the average of C of t. So C of t is the rate of fuel consumption of the tank. In gallons per minute from t equals 1 to t equals 5 seconds. And I made one of the errors that is very, very, very easy to make. I did not put my units here. Total fuel consumed from t equals 1 to t equals 5 minutes in gallons. And then the final problem, let's interpret r prime of 6. Oops. That should be c prime of 6. We don't have an r in this equation. So this is the rate of change. That's what the derivative means. Of c of t. And we said c of t is the rate of fuel consumption. So there are 2 rates in the problem. That's okay. The rate of change of the rate of fuel consumption. in gallons per minute divided by minute, so that's gallons per minute squared, at time t equals 6. Okay, for our final problem, let's do a check for understanding, and then we'll be all done. Water is flowing out of a holding tank at a rate of r of t equals 3e to the t over t squared plus 1 gallons per minute. For t equals 0 to t equals 10 minutes. If there are 1,800 gallons, or 18,000 gallons in the tank to start with, how many gallons are left in the tank after 10 minutes? Round to the nearest gallon. Okay, try that one on your own and restart the video when you're ready. Pause the video now. Okay, so gallons left equals gallons at start minus number of gallons that flow out. So we know the number of gallons at the start, that's 18,000. And the number of gallons out from 0 to 10 minutes is the accumulation, because we have a rate flowing out. So from 0 to 10 of r of t, that's 3 times e to the t over t squared plus 1 dt. This you can just do the calculator. Math 9. 3 times e to the t, or x, whichever you want to use, divided by variable squared plus 1. Make sure that denominator is in parentheses, or it's going to completely mess everything up, because the 1 won't be in the denominator. It will be just sort of a plus 1 afterward. The variable is x, going from 0 to 10. So that tells us, we round up, so 860 gallons flow out, and if we do 18,000 minus 860, that gives us 17,140 gallons. That concludes these notes.